Hi there! This is now the third video for unit number 2 concerned on rational exponents. This video will mainly be concerned on the demonstrations and discussions on practice exercise C of lesson number 1 of the same unit. Lesson number 1 still talks about the reviews on laws of exponents already covered during your grade 7 and grade 8 years. So let me share to you right now the material I provided you, the module on lesson number 1. For the previous two videos, we talked about the basic concepts of exponentiation in practice exercise A. And finally, for practice exercise B, we talked about the application of the first two laws of exponents. As for practice exercise C, the concern for this video, it will still be using the concepts learned in practice exercise A and practice exercise B. But we will be adding here the concepts of the remaining laws of exponents. The law of zero exponent, the power rule or the power laws of exponents, and finally the law of negative exponents. So we have only two numbers here, but it will cover the rest of the laws of exponents. So let us now I'm going to share to you right now the area where I placed the material or the practice exercise C. So we only have two numbers here. So let us create better spaces, 1 and then 2. Okay, well, I purposely place only two numbers because just by answering these two numbers, we're actually covering already the whole loss of exponents. Number one, in number one here, we have the expressions of the same base m. Okay, this looks like similar to your number one of practice exercise B, but here present is the applic the here is the presence of the law of zero exponent, and probably later on we will apply the law of negative exponents. The application of the law of negative exponents, that's why it was placed as the fifth law, is for it to be applied at the last portion. So we will apply first which laws are discussed first. So multiplication, division, zero, power, and then uli na po yung law of negative exponent. So to answer this, we could actually just I could give you two different methods. Okay, to which it's up to you kung saan kayo mas comfortable. M to the power of zero. I'm going to tell you the first uh, process. M to the power of zero here can be already simplified to 1 because any number by exponent 0 is always equal to 1. So it's not m to the power of 1, huh? It's 1. It's the whole, it's a factor, a whole integer 1. So just by simplifying it into 1, we can just simply combine the four expressions. So m to the power of negative 6 plus 7. These are all under multiplication law. So never mind the 0, plus 2, and plus negative 4. Okay? So if you are not going to simplify m to the power of 0 as 1, well, this is your second method. M negative 6 plus 7, this is 7, plus 2, sorry, 4 plus 2 plus 0, not plus 1, because m to the power of 1 is different from m to the power of 0. Okay, the whole quantity is 1, not m to the power of 1, plus 0, plus 2, and plus negative 4. If you look at the two different expressions, you're just the only difference is you're just adding here 0. But if you will add 0 to any number, the number will be the result. Okay. So again, I'm presenting you here two different methods. Number one is if you were going to simplify already m to the power of 0 using the law of zero exponent, it's okay. But if you will not, you simply apply the multiplication law. Do we have the same answer here? So I'm just going to use the first method I have presented. Kasi, again, if you will use the second method of adding 0, it won't I don't mind as long as you will follow the rest of the operation. It's still correct, but I'm just going to use here cancellation of m to the power of 0 into 1 so that we could apply the third law. Now this would be equivalent to m to the power of this the sum of the integers in the numerator. Negative 6 plus 7 is positive 1, plus 2 is positive 3, plus negative 4. The answer is negative 1. In short, our answer here is m to the power of negative 1. Again, let us repeat. You have here negative 6 plus 7, which is 1, plus 2, which is a 3, and plus negative 4, which is negative 1. Okay? So in that case, this is the result when we use the multiplication law. Now, we have here a negative exponent. In mathematics, we don't actually necessarily stay with negative exponents because it's not, uh, what do you call it? It's not stable. But when you say not stable, take note that the exponent is a signal of how many times the base is multiplied to itself. So if you have x to the power of 5 or x to the power of 5, the 5 there means there are 5 x's multiplied to each other. If you have y to the power of 10, that means there are 10 y's multiplied to each other. But if you will have m to the power of 1, you have negative 1m multiplied to each other. That is why it's not stable. So instead of using a negative exponent, we will use the last law of exponent, the law of negative exponent. We need to make the exponent positive by reciprocating it. Yeah. M to the power of 1. Okay, we move it down. And of course, we need to simplify this further. Yung wala na pong exponent na 1. 1 to the power of m. So this is the final result for number 1. At the moment nga, kung yung time na hindi pa natin na-discuss yung law of negative exponent, this is already acceptable. But since we already talked about law of of negative exponent, this is the one that we will accept. Number 2. Okay. Number 2 here talks about we'll use the concept of law of negative exponents, law of zero exponent, and the power rule or the power law. So let me copy it here. Right? As mentioned earlier, the laws of exponents are arranged in such a way that which law came first, yun yung the first one to be applied. So we have here negative exponents. Do not apply it first. Okay? We will use whichever comes first. So we will use muna power rule. So power rule tells us that we need to share the exponent here to all terms inside. That includes the numerical coefficient here. And by sharing, the process of the exponents now will undergo multiplication. So you have 2 to the power of 1 originally times negative 1, x to the power of 2 times negative 1, and then y to the power of 1 times negative 1. That is for your numerator. For denominator, do the same thing. Share it to all terms, which also includes the numerical coefficient. So you have 3 to the power of 1 times negative 2. Okay. And then x to the power of 0 times negative 2. Using power rule, we are now multiplying exponents. Which exponent? The exponent outside the expression and the exponent of the coefficients inside. So to simplify it further, this becomes 2 to the power of negative 1. We have x to the power of negative 2, y to the power of negative 1, all over 3 to the power of negative 2, and x to the power of 0. Because 0 times negative 2 is still 0. Okay? Now, we can use the law of zero exponent here. We can just simply remove this because that's equal to 1. And then apply the law of negative exponents to make sure that all the exponents will be positive. So what will happen here is that this 2 to the power of negative 1 will replace in the denominator. Positive na rin ang 1. X negative 2 will replace here, and the exponent will be positive 2. And y to the power of negative 1 will be placed here, and the exponent will be positive. 3 to the power of negative 2 will be moved up, So you have 3 to the power of 3 squared. And again, x to the power of 0 is already simplified as 1. So no more placement of 1 anymore. The final answer is the simplified form of this step. 3 squared is 9 over 2x squared y. As you can see, the numerator contains a what you call it, integer 9, and the denominator contains integer 2. So no need for it to become what you call 4.5. No need. As part of our discussions during your grade 7 years, if the answer is a fractional form, in this case 9 and then over 2, stay as it is. And of course, no need for it to be mixed. Stay as it is. As long as simplified na po siya. Kasi yung 9, it cannot be divided by 2, nor it contains factors that will actually be cancelled out by denominator 2. So these are the two numbers that will complete the review on laws of exponents. The purpose of reviewing these laws of exponents is actually attached on the concern that our next lesson is about another type of exponent. What we have been talking for this lesson, lesson one, are all about integral exponents. Integral meaning the exponents are integers form. In integers, you have law of zero, you have law of negative exponents, you have multiplication, division, and power rules, which are all applicable, which all represented in this lesson by integers. But we also have fractional exponents. And all of these laws are still applicable for fractional exponents. We will talk about fractional exponents on the next video concerned on the next lesson. Now, use this video to practice more on simplifying expressions involving exponentiations. Hopefully, you've learned something. Thank you. See you next time. Goodbye.